Here we are in section 5.1, exercises 25 through 34, and we are still multiplying polynomials. So let's go ahead and multiply them through. We'll take this 7l to the 10th and jump it through, and we get 49l to the 20th power plus 35l to the 10th m to the 12th. Boy, those are big exponents. Now let's take the next one, this negative 5m to the 12th, and jump it through. So we get a negative 35 l to the 10th m to the 12th. Wow, and then minus 25 m to the 24th power. And look at what happened. The same pattern is occurring that when we multiply two binomials that just have the opposite sign in the middle, notice the front term has the same sign, that the middle terms completely go away. They're like terms, and they're exactly opposite of each other. So we get 49 l to the 20th minus 25 m to the 24th. The other thing that we should notice in this pattern is that these are perfect squares. That's 5 times 5 and that's 7 times 7. If they're the same, then these numbers will end up being perfect squares. Cool. Number 26. 6n squared minus 1 squared. You might be tempted to just make it 36n to the 4th plus 1 by taking that squared in, but this minus sign requires that we do distribution. So this is actually 6n minus 1. 6n squared minus 1 times 6n squared minus 1. So when we jump that guy through, we get 36n to the 4th minus 6n squared. Now we need to distribute that negative 1 as well, that super distribution. That is minus 6n squared plus 1. Now when we see what that does coming together, these two middle terms don't cancel, and we get 36n to the 4th, which we thought we were going to have, but now we have a middle term of minus 12n to the 6th, which if you look is just double that number, plus 1. Great, let's try another one. 11p plus 3 all together squared means we really need to write it as 11p plus 3, 11p plus 3. That's what squared means, is the whole thing is timesing itself, and since there's a plus sign in there, it means we have to distribute. So we've got to go like that, and we get 121p squared plus 33p. Now when we jump the second kind in, let's do that right there. We go and we get plus 33p plus 9. Notice how different this pattern is. Instead of having two things that are exactly opposite of each other, we always get the middle terms that are exactly the same. So when we write out the solution, we get 121p squared, that's 11 squared, plus, notice this is 66p. It's exactly the 11 times the 3 doubled, and then plus 9, which is 3 squared. Good. If we can start recognizing these patterns, it'll make it easier for us later on. All right, next one. Ooh, this times that times that. Shouldn't make any difference whether we take these two and times them together or jump the 4p into that one and then do that. So I'm going to take these two right here and jump those two together first, because look at this pattern. That's nice. That'll put it together nicely. This is p to the 4th plus p squared. And then if we do that again with this guy, we get minus p squared minus 1. So these guys go away. So the problem that we're left with is 4p times p to the 4th minus 1. And then jump that guy in, and we get 4p to the 5th minus 4p. Good. Number 29. Ooh, this has a q plus 6 squared, so that's really this q plus 6 squared. We're going to write over here as q plus 6 times q plus 6. So that'll give us q squared plus 6q, and then the 6 jumping in gives us a plus 6q plus 36. So altogether we have 2q q squared plus 12q plus 36. That's what q plus 6 squared is. So then we can now jump it in without any problem like this and write our answer as 2q cubed plus 24q plus 72. Oh, that's a squared. 24q squared. Sorry, q times q gave us q squared, and then 72q. All righty. The next one, number 30. Oh, we got to jump the m into all three of these. So we get an m to the third power minus a 10m squared plus 25m. Binomial times a trinomial, we're going to end up with 6 terms down here at the bottom. Okay, take the 5 and jump it in, and we get plus 5m squared minus 50m, and then plus 125. Whoo-wee, that's a big long one. So we have 6, but luckily 2 of them combined together, so we only have to write out 4 terms. M cubed minus 5m squared minus 25m, and then plus 125. Cool. All righty. Number 31. Okay, let's take the x and jump it through, and we get x cubed plus 3x squared minus 9x. And then take this minus 3 and jump it through with a different color here. There we go. And we get minus 3x squared minus 9x minus 27. Oh, plus 27. Okay, so we get, something canceled. Those 3x squareds canceled off of there, and we got x cubed minus 18x plus 27. Alrighty, nice. All right, number 32. Oh, this is that cool pattern again. We have u to the 4th minus u squared, and then when we jump the 1 through, we get plus u squared. Oops, do it in that different color there. Plus u squared minus 1. The u squareds go away, and we are left with u to the 4th minus 1. Alrighty, number 33. 7x minus 4 squared is, let's just write it out here, 7x minus 4. And then we jump the 7x in, and we get 49x squared minus 28x. And then jump in the negative 4, and we get minus 28x and plus 16. And that same pattern emerges, 49x squared, and then 7 times 4 doubled is minus 56x. And then we get a plus 16 on the end. Excellent. And then number 34. W squared goes in, and we get w squared y. Plus w squared z squared, and then x squared goes in. We get plus x squared y plus x squared z squared. I don't see any combining at all, so that looks like our answer. A true binomial times binomial giving us 4 terms. Good.